We're going to review here for lessons 1-4 through 1-7. One of the things, if you look at lessons 4 and 5, was on dividing with fractions. One of the key elements there is the idea of reciprocals. If you remember, we talked about for dividing fractions is keep, change, reciprocal. So keep, change, reciprocal. If I steal that reciprocal there. And what that means is we keep our first fraction. First fraction stays the same. And then we're going to change the division to multiplication. And then we're going to do reciprocal of the second fraction. Again, reciprocal of the second fraction. Basically, you might think of it as flipping the fraction. The numerator and denominator switch spots. Okay, we're going to call it reciprocal, not flip though, because flip is not a mathematical term, but that's kind of the idea there. So one of the things you could be asked even on the test is just, what is the reciprocal? So we could say, you know, what's the reciprocal of 2/5? Reciprocal of 2/5 would be 5/2 would be our reciprocal. Again, just switching our numerator and denominator. You might see one like this, in which case you might say, well, I don't even have a denominator. How can I do that? Anytime we have a whole number, we can put that over 1, and then the reciprocal would be 1/4. Now, just a distinction for you guys, understand, I'm not putting an equal sign between these. In other words, 4 is not equal to 1/4, okay? We're going from 4 to 1/4, which is our reciprocal. No equal sign, just an arrow to show that's being changed to reciprocal. The last idea you might see would be something like this. And so occasionally I'll have somebody do this and they'll say the reciprocal is 3 and 4/1. It is not 3 and 4/1. So what we need to do here, first of all, is write this as an improper fraction. Writing it as an improper fraction, I could say equals, because these are equal. 3 times 4 is 12, plus 1 is 13/4. So 3 1/4 is equal to 13/4. I'm not done yet, though. I still have to find the reciprocal. Reciprocal would be 4/13. Okay, so that's how we find reciprocals, first of all. So let's look at some problems here, starting with number 1. They want us to find 7 divided by 1/2. So for this problem, first of all, the 7 you could write as a fraction, 7/1. 7 divided by 1 is still 7. And then we are ready to go here. Keep, change, reciprocal. Whoops. Reciprocal, I did not do. There we go. When you multiply that, it would be 14/1. 14 divided by 1 is the same as 14. So the answer is 14. That one we could kind of think about. Like if you have 7 pizzas and you split them all into halves, then you're going to have 14 halves. Might be able to think of that. Okay, let's go down to number 10. So number 10, 7/12 divided by 3/4. So we can keep, change, reciprocal. So 7/12 times 4/3. If you want to at that point, you can reduce factors, numerator and denominator. If not, we'll go ahead and multiply across. 28/36 is what we'll get. Those, if nothing else, you might notice are both even. If you reduce by 2, it would be 14/18. You might have to divide that off to the side to come up with the 18 anyway. Then we can divide by 2 again because they're still both even, and that's 7/9. Since I divided by 2 twice, I could have actually divided them by 4 and gotten straight to the answer, but again, as long as we get to 7/9, we're in good shape there. Lesson 6 was on dividing mixed numbers. So if we look at number 1, 6 3/8 divided by 4 1/4. So just remember on these problems, we got to take our time with what we're doing. Otherwise, we will make mistakes here. We have to change to improper fractions first, then separate step, keep, change, reciprocal. So we change these. 6 times 8 is 48, plus 3 is 51/8. 4 times 4 is 16, plus the 1 on top is 17/4. This is still a division problem. So now we've got to keep, change, reciprocal. This is going to be probably hard for us to detect. 17 times 3 is 51. So normally we haven't been doing this. Since this is multiplication, if you want to reduce these down, you can. I'm reducing those by 17. The 4 and the 8 I can reduce by 4. If you do it that way, you'll get 3/2, which is the same as 1 1/2. Okay, now I'm just showing you on that one because the numbers are not real nice. You would get 204 over 136. Is that right? If you did it the other way. You can divide it out and then reduce it. You'll get the same answer, but 17 and 51 was not normally a number that we would be able to detect easily. Lesson 7 is another thing, has multiple steps. We might get into looking at that later. These are just some word problems that we could see. Remembering that in real life, someone's probably not going to come up to us and say, what's 5 divided by 1/3 outside of math class, but we might have a situation like this. A rope 10 meters long has been cut into pieces that are 2/9 of a meter long. How many pieces will there be? So we're starting with a 10 meter long rope. We're dividing it into 2/9. So 10 divided by 2/9, and keep, change, reciprocal, we can work that out easy enough. If you divide, you'll get 45 pieces. Okay, again, mainly is that we understand what the setup would be. You guys are good from there. So here, lesson 7, Daisy has one cucumber 3 inches long, another one is 5 inches long. She cuts them into 3/8 of an inch thick slices and adds them to a salad. How many 3/8 inch thick slices does Daisy have? So it says, first of all, write division expressions to represent the first steps of the problem. In this one, if they didn't say this to me specifically, I'm going to suggest maybe let's not answer their question here. We're just going to solve this thing because they're creating more work for us than what we really have to do. Probably what I would do on this problem, first of all, is let's see all together what we've got. We have 3 inches and 5 inches is a total of 8 inches. That would be my first step. I'm not going to do a division problem first, realistically. Okay, let's do this the easy way. So at that point we have 8 inches total. We're dividing it up into 3/8 inch slices. Now we can keep, change, reciprocal and work that out. So it's 21 1/3, and so that just means we'll have one of the slices will be a little bit smaller, but technically for the 3/8 of an inch thick slices we'll have 21. understand really we'd have 22, just the last one's going to be a little bit smaller because we ran out. Another word problem here. Some friends are making cakes for a bake sale. In all, they need 6 cups of sugar. However, they only have a 1/4 cup measuring cup. How many times will they need to fill the measuring cup? So for this, basically we have the 6 cups of sugar. We're dividing it to see how many fourths that we need. Keep change reciprocal. And it would be 24 times they would have to fill this thing. Or they could hope that they have the other ones dirty. They could just wash it if they wanted to, but that's okay. 24 of these times they could fill it. Students in a cooking class made 4.5 quarts of soup. They served 4/5 of the soup to friends. Each serving is 3/5 of a quart. Hector incorrectly says there were 3 3/5 servings of soup. What is the correct number of servings, and what did Hector do wrong? Okay, this is like what we did in the last section. So first of all, we have 4.5 quarts, and we served 4/5 of the soup. Means we're probably going to multiply. So 4.5 times 4/5. Have those as improper fractions and multiply. Be 36/10. We can reduce that if you want. We could change it to a mixed number. 18/5. You could change it to 3 3/5 if you wanted to. That's how many quarts that they served. And each serving's 3/5 of a quart. So it's actually kind of going in circles a little bit. If you change to 3 3/5, that's fine. You're going to take 3 3/5 divided by 3/5. You want to see how many 3/5 you have in the 3 3/5. And what I mentioned is that if you just keep that as 18/5, that's what you're going to be going back to anyway. You have to have it as an improper fraction to work this part out anyway. So just something to think about. So keep change reciprocal, make sure we do that part. And then you could reduce these if you wanted to. The 5s we could reduce down to 1s. The 3 and the 18 you could reduce by 3. And then that's 6/1, which is the same as 6. So 6 servings. So basically, if we were working this out, it said Hector said there were 3 3/5 servings of soup. So all he did actually was find how many quarts that they served. He didn't find how many servings that would amount to. And last problem we're going to look at here, hairdresser combined 3 bottles of shampoo into 1 bottle. So the first bottle had 4.8 ounces, second bottle had 5.4 ounces, and the third one had 6.6 ounces. And so they combined them together, and then the hairdresser used 2/5 of the shampoo from the new bottle when she washed her hair. How many ounces did she use? Alright, so the first thing, you might have figured is that we need to combine these bottles together. And when you do that, make sure your decimal points are lined up. Always when you add or subtract decimals. So 16.8 ounces altogether. Ounces, they abbreviate sometime OZ. So 16.8 ounces, and then she used 2/5 of the shampoo. There's that word of again. A lot of times means we're going to multiply. So we could do 2/5 times 16 and 8/10. The 16 and 8/10, you can change that to 16 and 8/10 mixed number, and then you could reduce it. You could change it to an improper fraction. It's actually really a lot more work than what we would probably have to do. I'm just going to keep it as a decimal because that's going to be less work here for us. So we'll just multiply straight across. And then divide that out. So 5 goes into 33 6 times. 5 goes into 36 7 times. And then we'll have to add a 0. 5 goes into 10 2 times. So she used 2/5 of it, so she used 6.72 ounces. So that's, again, trying to give you guys a little bit of an example of some of the word problems. Again, understanding some of the ones that you might see, you could have multiple steps. More than 2 steps is definitely fair game, as you've seen on the problems that you've worked to this point. So again, highly recommend the PearsonRealize.com website to get some more practice on these problems. And again, make sure you look over some things, look in your notes and look in your book, kind of go through it again and refresh all your memories on how this all works.